when you are undertaking research, so I want to welcome you to this lecture. When you're undertaking your research, what happens is that you will normally gather data. And after collecting data, what you will usually do is, before you start applying any machine learning model, before using any particular machine learning model, you need to look at the data. You need to make sense of the data. You need to ensure that the data meets those specificities, specific guidelines, for undertaking the data, for dealing with the data. And so what is happening, this thing hasn't still shown. Just a second, please. All right, do you guys see the screen? Because it looks like only part of the screen is showing. Okay, let me show the entire screen. Confirm with me if you can see the screen. Do you see the PDF?
Yes, sir.
Okay. So you get data, and by the way, this whole program you are doing, it requires that you have data in all your work. And research requires you to have data. So you will gather data, and because I'm walking you through the quantitative part, you are going to focus on the quantitative data, which basically is about numbers. So we're going to be focusing more on numbers. Now, once you've collected data, just like the one I have given you last time, and we are still using it today, once you've collected the numbers, you've got to make sense of the numbers. So the last time we looked at the descriptive statistics and contingency cross-tabulation analysis of the numbers. Remember, when you don't understand something, it's prudent that you ask me instead of waiting and allowing things to flow. Now, after you've done the descriptive statistics or summary statistics, you could then go ahead and look at visualizations. So today, my concern is to look at visualizations with you. How you can visualize specific things of the data to make sense of it. And what are visualizations? Well, in data science, in machine learning, in artificial intelligence, in business analytics, there are key Python, notebooks for data visualizations. There are several libraries for data visualizations. The popular ones are Matplot libraries, Seaborn, okay, Plotly, Bokeh, okay, Pygal, Folium. These are key. And with these, you can do a lot of things. There are other complex ones, like Plot9, like GeoPlot library, like GleamAlta, and other things. I've given you a link for you to see several of these, but the key ones, we are going to do them today. Okay. We shall look at Python charts that focuses on distributions. So if you want to look at the distribution of data, which is usually defined by the spread, the variability. So if you could remember, in descriptive statistics, we have the central tendency, the mean median mode, and then we have those that look at the deviation from the center, which has to do more with the variance, the standard deviation, the kurtosis, the skewness, and all of that. That is where distributions come in. And there are some lovely graphs that will help you to be able to understand each one of these distributions. Now, we are going to look at some of them, so I will not even mention them now. Then you will also look at correlations. We will not look at that today, but there are several graphs. We'll look at some of them actually today. There are several graphs that can handle correlations. Okay. We'll look at quite a number of them today. And then there are graphs that also look at bar rankings. We shall look at some of these rankings. Part of a whole. Okay, part of a whole, we are not looking at any one of them for this purpose. There are graphs that look at evolution. We'll look at them. And then those that look at the world map or city map. We will not look at any of that today. There are graphs that look at flows. Okay, flows. You will need some of these graphs when you are doing artificial neural networks or convoluted neural networks. Okay, or different aspects of deep learning. If you are doing that, you will need some of those graphs. Okay. So what I'm going to do now is I'm going to switch over to Python, and then we'll go through each one, some of these graphs, very importantly, because you get them in exams. And then you will see the nature of them and the sort of questions I'll ask you related to them. So I've turned on to the Gene dataset, the Burukutu Ventures Gene dataset. I'll remind you of what the dataset is. You have that same dataset with you. Please load the libraries, all the key libraries, NumPy, Pandas, CMON, okay, all of the necessary packages. And I think the first 4 are enough for this purpose we are going to do. Can you confirm if you see the screen of the Gene dataset?
So we can see it.
Super. I'm going to load it, and I want you to do the same thing by loading it. Okay. So this is the data set. I'm loading the packages for the purpose for which we are going to do. You have the data, you have the command. Follow me along as I walk you through this process. So that should load the packages or the libraries. It's done. Now we can load the data. For example, if I run this thing right now, it won't work. Oh, it has worked because I've already loaded. Okay. So this loads the data. We've decided to call the name of the data set here in Notebook. We've called it DF for simplicity. This is the first part of the data. We've done this already last time. And this is just the tail of the data set. All of these series of other questions, we've looked at all of them the last time we met. My focus today is to look at charts. And the first one that we are going to look at today is line graph. Now you might be wondering, what sort of questions am I going to be asking you regarding these charts? You'll see them as we go. So here you have this chart. Regarding assignments, you'll be given a data set for you to generate a lot of graphs and interpret a lot of graphs. You get that. Regarding exams, I will generate graphs for you and ask you a series of questions about them. So just so that you know. All right. Now, let's go to the first one, the line graphs. Line graphs are very useful. You can use it when you want to examine the evolution of a particular variable, okay, numeric variable, or several numeric variables at a go. Okay, especially when you have time series. And Seaborn and Matplotlib library will help you to be able to do that. Now, the data set I have given you, this data set is actually not a time series data set. It's a cross-sectional data set. It's 1 year. It's not changing over time. So the quantity demanded of GeneBitters, the price of GeneBitters, the income of GeneBitters, and then other factors like the complement price, which is C. And then you have the location, occupation, and religion. In case you've forgotten about the data, refresh your mind. It's at the top of your last Python notebook, the last Jupyter notebook. Look at it. Now, if those variables were changing over time, so suppose the quantity demanded for this year, for next year, for subsequent years, if they were varying over time, then you could do time graphs for them. For that to happen, as long as these packages are installed or these libraries are installed, you can run that. So look at the first one here. The first one here is actually plotting the quantity demanded of GeneBitters. That's the quantity demanded of GeneBitters. It is over time. If it was time varying, okay? If it was time varying, then you could have drawn it. But I had to do it for you. Even though this one is not time varying, I still have to do it for you to be able to appreciate what it is. The second one is about price. Again, using PLT plot, picking the price from the data frame called DF, labeling it as price. Now I want you to watch the line style carefully. If you check the style, it is column. And you're going to see how the column will look like there. And then, of course, the next one is income, and then which is M, and then complement price, which is C. Now, I want you to check that with a complement price, I've shown a different line system. You will need some of these things in your longer, say, project, dissertation, anything. If you check the line style, it is a minus and a dot. Unlike the income is just a minus, sort of, a dash. And this one is a dash and a dot. So when you now plot all of these, this is what you get. So if you check carefully, the complement price, I think I made a double statement. In fact, you can actually use two names. Let me just use actual name. Let's call this quantity. Okay. And then let's call this price. And let's call this income. And the last one, let's call it complement or comp. Okay. Comp price. And then let's run it again. You see that the legend should obviously change. If you check carefully for the complement price, you will notice that they are bigger because the line width I've increased it. In fact, let me make it even extra bigger for you to see. So let's move it to 5 instead of line width being 3. And watch what happens. So you can see that the line width are bigger for complement price now. And you would also see, now the reason why you have to use these line style is because sometimes when you submit your work, it will all be in black and white. I'm talking about physical, when someone prints it. And when you do all of them the same thing, like the first one, the same style, then it will not be clear as to exactly which one represents which one. So it's always nice that you assume in your mind that this thing, if it were black and white, will people be able to distinguish between this line and the other line? And that will help you to know how to go around it. So this will generate the whole thing, as you can see. Now, if you want to change the size, that's the height, and that's the length. Okay? If you want to change the length, you can use a figure size to change the length, or you can use this one to change the height. So for example, if I should change this to 8 instead of 6, the height, sometimes the height will increase, okay? And you're able to get a bigger, better height than the way it is supposed to be. All right. So that is how you indicate the line. Remember that the idea is that what is on the x-axis is supposed to be time. And what is on the y-axis is supposed to be the specific values or anything. But because there's time not involved, everything is measured by virtue of observations. Remember that the values for the quantity and the complement price are big. In fact, if you want to see that, if you go to the data set here, okay, and you check the means, you see that the quantities and the complement price, they are bigger values if you check the means, 175, 125. But when you look at the income, which is a M, and the price, which is a P, you will see that the values are smaller. That is why those graphs are showing at the bottom, because they are smaller there. Okay, that is why they are showing at the bottom there. Now, remember that there are several other ways that you can actually show some lines. Let me see if I can think about another way of showing a line. No, the screen is frozen. Okay, And there's one particular style, line style, I want to try and see whether it works. Nah, it doesn't work. Yeah, it doesn't work. Okay. It doesn't work. Let's try another one. Okay. So I've changed the style for the green one, and you can see that the green one, which is income, is now dash dash. At first, it was a straight away one. Okay. And then you have the other ones following. So there are several ways you should learn to master these things. And as you do them, it's very easy. Okay? You can always take this thing, copy output to clipboard, and then put it into your Word document. Okay, so that's a line. The next graph that you can look at are graphs that measures distributions. Distributions. What is a distribution? A distribution tells you deviation from the central tendency. How are certain things nucleated or scattered? How are they nucleated? You will notice that there are airways in the country and there are guns in the country. Even though there are airways in Accra and there are guns in the Volta region, you will notice that the geography will pinpoint the language as well. So the language is being detected in several parts of the country, but there are some regions that are having concentration of the language. So if you take Accra, it's got a concentration of the Ga language. If you take Kumasi, it's got a concentration of the P language. If you take the Ho and Mando, it's gotten the concentration of the Ewe language. It doesn't mean that the others are not there. So the distribution can tell you how a particular, in this case, a particular language is distributed. But I'm going to first of all show you how other things are distributed. And you can use histogram for it. The good thing about histogram is that it can tell you the distribution of a numeric variable, a number. It has to be a number. The number can be, it can be one variable or more variables, which are all numeric. Or it can be one numeric variable across different groups. We shall look at an example of that. So you will have bins, okay? Each bin is represented as a bar. And we are going to look at one of them. You see that the very example that we have here, it is designed to show you not just the histogram, but also the kernel density, or what is known as the density plot. Anyway, this one is for quantity. You can use the Seaborn command library, okay, specifically the displot, and you can use that to show this. So the data variable known as quantity, you can look at quantity, and the kernel density estimation has been made to be true to indicate that you want the kernel density to be superimposed. The color is sky blue. You can change the color to be blue. Then the ragged is very, very important because ragged actually helps you to, and I'll explain ragged as we go further. You'll see that very soon. Okay? It helps you to be able to know the timely concentration of the data set. You can also indicate the height and the weight, of the ragged. Okay. So if you look at this ragged here, it is true, which means I should show ragged. The ragged are those lines that are down here. You can see that the line weight of the ragged is 2, is 4 here. I can change it to 2 so that it becomes smaller. The height is 0.2. I can change it to 0.1 so that it becomes smaller, okay, or shorter. So now let's run this. Remember, the color is going to be blue. So in this blue color, you will see that the ragged has actually come down. Okay, let me change this one to 1, the alpha of the ragged. And you will notice that, of course, you can use another color. Just let me use green to hone on the point. And so the ragged controls the distribution as you might know it of the data set. But now let's look at the histogram. This is the distribution of quantity demanded. What can you say about it? Anybody can tell me what you can detect or you can say about the quantity demanded. How is it distributed? Remember, there are 40 observations. Okay, there are 40 observations. How do you see it? Straight away, you can see that the histogram is not normally distributed. What does that mean? Well, for a histogram to be normally distributed, it should be smooth, bell-shaped like this, something like that. And that is what we mean by normally distributed. And that also means that when you should draw the beans must all look like something like this, okay, something like that, okay, something like this. It rises, it gets to the point, and then it starts falling, it starts falling, it starts falling, it starts falling. Okay. So that is it. And the center here, as you join them, that center is what eventually leads to this smooth kernel density plot. So why is this important? Well, if your data is large, the histogram can help you to determine whether it's normal or it's not normal. Okay. And the fact that you have two modes, we'll come to that. You can see that the kernel density plot has got a peak which depicts mode, okay, or modality. It's got another peak here which depicts another mode, which means that this data set is exhibiting bimodality. So if you are actually talking about it, if I were to ask you to explain this graph, okay, identify two things that are unique about this graph for quantity demanded, you will say that the first observation is that it is not normally distributed. That's one. Okay, which of course means that because the kernel density plot is not bell-shaped, but also even the histogram itself is got ups and downs, and nothing, ups and downs, and nothing. But then for ones that are normally distributed, it's got up, and then down. And that is why it's not normally distributed. Second thing, what do you observe? You say that it exhibits bimodality, okay, which means that there's a high concentration of the data around the value, say 150. So much of the data points are concentrated around what? 150. And much of the data points are also concentrated around, what do you call it? Around 200, okay? And you can double check to see how that is actually true. So that's it. That's a beautiful thing about this very observations that you will be noticing right here. Okay. So if I were to ask you some of these observations, that is what you would have actually indicated in that. Next thing, you can check two variables. You can check the distribution of two variables, numeric variables, two variables that are numbers, as you can see right here. So here we are looking at income and then price, income and price. And you will notice whether or not they are normally distributed or not. Now, which one is more likely to be normally distributed? Price or income? Those are some of the observations. You can tell me. Which one is more likely to be normally distributed? Price or income? Which one? It is your answers that slow me down. When you give answers, it slows me down, not to fly, not to rush. But when you leave me to talk, I'll just be flying and nobody will probably understand. So you raise your hand and then you comment. Okay, so you notice that when you check carefully, you notice that the price is almost normally distributed, but then the income is exhibiting multimodality, specifically bimodality. Okay. And you will see that this is a different way of showing, unlike the previous one, which is using this plot, whereas this one is using histoplot. Okay. Now let's go to the next thing you can do. You can also split the figures. So instead of you having a big one, if you have a lot of comparisons you want to make, you can rather put all of them in one graph. So this first command here will indicate that I want you to have mini plots, which is called subplot. So once you take 1 and 2, you're going to get the plot as 2 columns, 2 rows, 2 columns. If you have 3 and 4, okay, sorry, 3 and 3. So suppose I change this value to 3 and 3. The idea is that you're going to have 6. Okay, you're going to have 3 rows. Is it 9? Yeah, 3 rows, 3 columns. Okay, unlike what we have here. And then when you run it, let's run that and then see. So you can see that he's left 1 there because that was the impression you gave that you want to have 3 by 3. Okay. But so you can put all your graphs in one instead of having one graph here, one graph there, one graph there. You can actually do 4 by 4. Okay. In fact, you can also do 4 by 2 or 4 by 3. Okay. So this one is 4 rows, 3 columns. You can do that, as you can see. So there are several ways you can adjust your graphing for it to look, let's go back to the 2 by 2, for it to look great. Now remember, each one of this is a numeric variable. So the first one is dealing with income. Okay, the second one is dealing with price. And then the others are also showing complement, price, and then quantity. You can see all of them are numeric variables. And just looking at this, oh my goodness, just looking at this, you can make some 3 comments. 3 important comments can be made on this. And those are some of the things I'll give you in an exam for you to showcase. Some of them are exhibiting platekinetic, okay, which will be shown in the way their ketoses are indicated. Some of them are showing bimodality. So if I were to ask you which one is showing bimodality, which ones are showing, positively skewed, negatively skewed, and all of those things, you should be able to have an idea about them. All right. Let's go to the next comparison, a box plot. That's the next chart. What is a box plot? A box plot tells you, again, the distribution of a numeric variable. That is it, the distribution of a numeric variable. Now, the numeric variable can be one numeric, can be one box, okay, one particular numeric variable, or a particular numeric variable across different groups. The advantage of a box plot is that you can quickly get the mean. You can get the median. You can get the quartiles. First quartile, second quartile, third quartile. The second quartile is the median. Okay, you can get that. It can show you some outliers in the data, abnormal observations. It can also show you whiskers in the data. The whiskers here are those lines extending from the box itself. The box is actually exhibiting 50% of the data set. The whiskers are those lines extending from the 75th percentile, okay, which is the third quartile, and then you have the one extending from the 25th percentile but downwards. Okay. Those whiskers, they tell you the range of the data set, excluding the outliers. If there are outliers, the outliers will automatically be shown in the data. So outliers are shown automatically. You don't need to go and force it to come. If they are there, they will be shown automatically. Okay. They are extreme values. They are not part of the data set, so they will be flagged out. Okay. And they are normally beyond the whiskers. They are beyond the whiskers. If you have a box plot that is very, very long, it tells you that there's greater variability in the data set. If it is not that long, it tells you the opposite. Okay. Sometimes the box plot can hide. So it's very important to display every observation of the box plot, okay, so that you can see all the patterns involved. And sometimes the box plot can hide. So I'll show you something else you can use to unhide what the box plot might be hiding. For now, let's generate the box plot of just quantity demanded. But I'm going to use that to just teach you. Okay, I'm going to just use that to teach you. So I'm going to use that quantity demanded thing and then tell you parts. So I've indicated so many things of this box, okay, that I want to show you. So let me do it like this so that it becomes better looking. I just run it again. You can do the same thing with yours. Now note that I have indicated that Python should show us the 25th percentile, which is the first quarter. I've also indicated that it should pinpoint the median of this data, which is the 50th percentile or the second quarter. Then I've also indicated that it should show us the third quarter, which is the 75th percentile. I've also indicated that it should show the whiskers, okay, the lower part, the lower whiskers and then the higher whiskers. So you can see that here, the maximum whisker is being shown at the top. The whiskers I told you are the vertical lines extending beyond the box. And where it ends is that small horizontal line. Beyond that, you will have outliers. The same thing, the whiskers below are down there. Below that, you will also have outliers. All right. Now, so all of those things that you want to be shown, they are being shown. And by the way, watch it carefully. The calculation of each of these things are also indicated. Okay, so you can see that there's a command I have given to indicate how to calculate the 25th percentile or all the percentiles. And there's a command which is coming from the actual equation for whiskers. That is showing the lower whiskers, okay, and then the upper whiskers. How that is done is all here. So once you run the thing, you'll be able to see, you are able to pinpoint on the graph. In fact, even and this is interesting, the way you want the writing to be done, even that, I've shown it here. So I want the median to be written. The median has been written. The color of the median, that should be written, is shown there. The third quarter, the color is supposed to be blue. The first quarter is also supposed to be blue. They are all there. But when you look at the whiskers, I've indicated that they should be gray. So again, you see that each of the whiskers, this is just for quantity demanded. So it can give you an idea. Do you remember that the quantity demanded of Jim Bitter's kill was approximately 75? In case you've forgotten, when you go to the descriptive statistics here, it will remind you. So look at the mean and then the median. If I look at the mean is 175. And look at the median. The median is a 50th percentile. It's also 175. So you see that the mean and the median have got the same value. So when you come here, when you come to the graph, okay, you can see that the median is the center of the box. And when you look at this box, that is the median. It's not the center of the observations, but of the box. And when you trace it to the left, you see that the value is approximately 175 on the left. That is for one numeric variable, nothing else. What about if you have one numeric variable, but you want to compare across groups? In case you have forgotten, you can open your Excel sheet and look at what I'm about to say. We can have two box plots and compare them. For example, we in our data set, we know that we have a quantity demanded of gene bitters, but we can look at a quantity demanded of gene bitters across location. What do I mean by across location? What I mean is that you have the quantity demanded of gene bitters between urban shops or shops located in an urban area and shops located in a rural area. That is two separate groups. And you can use this to indicate that. So this command is just a command that's, and watch it, you always bring the classification first, the cluster first. So the group here is location, represented by LOC. That must come first, which is the X variable. That's the one on the X-axis. And then the one on the Y-axis is the numeric variable. Okay. Remember, this one on the left axis is the categorical variable, or in this case, a dummy variable. And they are the ones going on the axis. So if the data is so big, you can still quickly use this graph to compare. Okay. Now, this has been given a color of red. Suppose I remove the color of red, okay, and run the data, it will use the default color, which is what you see here. All right. Now, what can you observe from this? Very, very simple. You can observe that, and by the way, look at the bottom here. The bottom tells you the names of these locational shops. You will observe that the urban centers, they consume more akpeteshie, more quantity demanded than the rural areas. That's one first observation. How do you notice that? Well, look at the median. The median there is approximately 200. And then when you check for the rural centers, the median there is approximately 140 something. So it clearly tells, and by the way, the median is the center of the box. So it can quickly tell you that it appears much of the people in the urban centers, relative to their number, by the way, are those in the rural centers. Remember that you can go and check the descriptive statistics for each one of this to know the actual numbers for each one. And you can check not only the descriptive statistics of quantity demanded, you can do it for price. You can also do it for any of the other independent variables, except the categorical bounds. So that is one thing you can quickly observe. Okay? You will notice that majority of those that are there are actually, majority of those that are in the urban center are consuming a lot of akpeteshie, a lot of quantity of gene, whereas those in the rural section are doing less of the absorb. But there's another observation. Who can sense it? Who can sense the observation? Think about it. Why is the rural on the right side and then the urban on the left side? Think about it. But that's another thing you got to find out. Think about it, because I'm telling you things I've set questions on. Okay. All right. Let's go to another plot that you can use in conjunction to help you bring out a box plot. I told you that a box plot doesn't bring out things properly. And it is the strip plot or the swarm plot. It tells us it can help us to add points to the box plot. Why? Well, here's the thing. The box plot can hide some observations, because what it's doing is that it's giving you box. So you can hide some observations. So by introducing the strip plot or the swarm plot, in addition, superimposing this on the box plot, you will be able to identify where each observation is. Okay. For example, if you check this one, and I decided to do this with a different one. Okay. So this time I'm not using location again. I'm rather using religion. Remember, in the data set, there are 3 levels of religion. We have the Christians, the Muslims, and the Buddhists. Those are the 3 religious groups. Now, so we are generating the quantity demanded across those 3 religious groups. The background, as you can see, the size, everything. Now, in terms of the box plot, that is the first command here. And by the way, the box plot, you can make a different color. You can add a different color to it. So you can just go here, copy this color, come down here, and then paste this color here, and you can change the coloring. You can just change it, let's call it purple. And then you can run the command, but also the second one here is the strip plot. So you are adding the strip plot to the box plot. Okay, and then we categorize them across religious groups. So that is the result, purple. Okay, so you have the purple showing clearly. Now you can see that I have indicated that the color of, and I had to do this multiple times so that the color will pop. I have indicated that the color of the strip plot should be white so that it can pop. Okay, it can pop. And you can now see the observations. You can now see where each observation is located. Remember, we have 40 observations here. And you can see where each one of them is located. First of all, by looking at this graph, you'll be able to quickly tell that Christians are consuming more of Akbatesh. And you can see that because the box on the far right is for Christians. They are consuming a lot of Jimbetes. Who can tell me another observation? Who are consuming the lowest of alcohol? Which religious group consumes the lowest alcoholic beverage?
So the Muslim.
The Muslims. The Muslims are consuming the slightest. And then, of course, the Buddhists are in between these 2 religious groups. So the box plot can show you. And you will notice that if you check carefully, Muslims, much of the concentration. Now, let me ask you something. If you look at each one of these, what can you say about those that are, because remember, the median shows the center. And where the median is can tell you the concentration. Okay. So the concentration, because the median is the black lines, and I don't know whether this color is good, but I think that maybe let me try red. Yeah, red pops out well as well. So when you look at the median, what does the median tell you across the 3 religions? What do the medians tell you? Who can guess? It's not a common thing, but when I check my questions, that's when I'm able to ask you some things. What does the median tell you?
So I think when you look at the graph, the median is up, the observations at the top of the observation instead of maybe at the middle. It's concentrated at the top.
For which one?
For Buddhists.
Or for all of them?
I think for the 3 bars, the Buddhist is more observable, is higher than
Very
the
good. Excellent.
Christian and the...
Good. So that brings me to my question here. My question is, what does a median, which is towards the upper part of the box plot, tell you?
I mean, it's skewed. It's skewed, whether, but I can't say whether to the right or to the left, unless I see it on a...
What it basically means, who can guess? What it means is that there's more data values clustered towards the upper end of the range. That's what it means. It means that the lower quartile, okay, the lower quartile to the median has a wider spread than the median is to the third quartile. And it's true. If you look at it, that median being at the top means that there is more, like there is a chunk of the box, you know, towards the third quartile. That's what it means. So for example, when you look at Buddhists like that, by this thing going upward, it means that majority of the space here are towards this lower quartile. Now there may be low values. That's what it means. Pulling the distribution here to the left. That's what it will mean. Okay. So these are some of the deep things that you could get. You know, when you have the median toward the upper box, it means that the data here is left skewed. Now, for the case of Buddhist, it means the data is very much left skewed. The data has got longer tail. That's what it means. Than what do you call it? Than Muslims. Muslim is almost getting to the center. It's like the median is actually exhibiting the center. But when you look at it, you see, when you rotate this thing leftward, anti-clockwise, when you rotate this anti-clockwise, you will see that this one here is more of a left side than a right side, isn't it? Or should I do it? Let me see if I can do, if I can rotate it, and let's see. Maybe, I don't know, I've not tried. Let's do vert equal to vert equal to true. Equal to false, because that's the default. Where is that? But you know what I mean. When you rotate it, I was just trying to show the rotation. When you rotate this thing leftward, right? You see that the median, you know, when you have the median towards the upper half, like you have in Buddhist here. In Buddhist, look at the Buddhist, the median is towards the upper half. There. That's the third quartile. It tells you that the data is more left skewed, longer, lower tail for the Buddhist than for the rest. But when you have it more towards the lower tail, okay, it means that the data is more right skewed. That is what it means. Take it from me. That is the truth of that. All right. So you can observe this right here. Let's go to the next thing. You can also look at beautiful graphs, because see, when you look at this graph here, one thing about this graph, carefully look at it, you notice that they are all showing red, 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 red. Okay, they are all showing red, red, red. So what if you want one to be of a different color? First of all, let's assume that there is not even a color, and you want it all to be drawn like black and white. One thing you can do is you can use these patterns to help you. So watch it. I'm going to do the same thing for religion, quantity demanded across religions. I'm still going to use a box plot using the CBON. But my interest is this very one here. You will notice that there are several patterns one can use. So look at that when you hash this out. Let me run it so that it looks smaller. So when you look at this graph here, and by the way, it's the same thing. Everything is there. I just created a hatch and then applied a pattern. So inside each box, there is a kind of a pattern. In fact, you can even have this thing as black and white. So let me remove the yellow thing so that everything becomes sort of black and white. Okay. And then let's see. So this one is a pure black and white thing that we can see here. I just changed the yellow to white. And you will notice that this pattern helps you to clearly not, they are all not looking like the first one, where they are all red, red, red. But then they are showing some beautiful, beautiful patterns in there. And the patterns are here. Watch this. The patterns are shown right here. The first one is division sign. And so that is why you see this to be division sign. Now, of course, you can change it. I could have used double division, or I can even use this one. Hash sign like this, which will now make the thing sort of going backward the other way around. Okay. What the patterns will do is that it will take the first three if your groups are three. So the first one is that division sign. Second one is kind of O, letter O. And then the third one is a star. So they will go in that order. Now there are other patterns that I have here, like times, like plus. For example, if I change this division sign to times, it's going to make the first one times. Okay, as you can see here. The first one now becomes times. So the graphs are there according to, the patterns are there in the manner in which you want it. As many boxes as you might want. And then of course, you can change the coloring anytime you want to change the color. Let's use sky blue, okay, as our final color here. And then you can also have it in sky blue, the way you want it to be. Again, this is a box plot. As you can see, it's a box plot. Oh, don't forget that the median is still showing. Oh, the median is still at the top part there. Based on this, you will notice that which groups tend to dominate, which religious group consume more akpeteshie. I think we've said it already, haven't we? The religious group that consumes more quantity demanded of jembitters are the Christians. And you can see the value of that. You can see the value of the consumption level using the median. So that's how you show it. That is how you show this practically. Okay, now remember that you can change the quantity demanded and replace that with C. Okay, by C, I'm talking about replacing that with complement price. Or you can even do price. Let me just try price. Okay. So you see price, everything changes. The Muslims are charging a higher price. Probably that shows why people are not consuming a lot. If you look at the Muslims, the price there is above 16. But then when you look at the Buddhists, the prices are around what? 14.5 and the median. And then you see the Christian, the price is very low. No wonder people are consuming more akpet, okay, in the price section. So there are several things that could be asked. Okay. So if I put this graph together with another graph, together with another graph, okay, let me show you an example of what I mean. Suppose I use subplot. Okay. Suppose I use subplot first. Yeah. I'm just trying to do something. Suppose I use subplot here, and then after this, I decide to also incorporate that. I am asking a lot here. I am asking a lot, believe me. First of all, see how it looks like. So you can see that this graph is showing with these other ones because I'm trying to show the path. But my point is that if I'm able to show multiple graphs on a page, let me try something. I'll just have to undo that. But if I am trying to show multiple graphs on a page, okay, like this, something like that, multiple graphs on a page, I could ask you several questions related to those multiple graphs on a page. So I just wanted to know that, you know, I just wanted to know that you should be able to learn how to interpret these scores the way that you're supposed to do it. Let me just go back. So the price is different. When you check it against complement price or income, let's look at it from the basis of income. So you just come here, change it to M, okay? And now let's look at the income patterns across religions. Look at that. You will notice that the Muslims are having less average income. Okay? The average income of Muslims around shops is around 15,000. The average income of the Buddhists around shop is 21,000 on average. And the average income around Christians is around 18,500. So you can see that you are able to get the different categories of the income capacities. And then you can relate that to any other thing that you want to relate. So let's change this to the quantity demanded, and we are back to where we were before. All right. I'm sure you get a point. Now, so box plot is good, but density plot is even better. What are density plots? Density plot or kernel density estimation, they are able to visualize the distribution, or they can show the probability density function of an integer, okay, for one variable or more variables. You can do that. If the data is very large, I'm telling you, it will give you a smooth curve showing the distribution of the data set. So this is kernel density alone. We used to have it under the histogram. Remember when we gave the histogram, we gave the kernel density alongside it. But this time, because it's using the Silverman's reflection method, you can single it out and talk a lot about a kernel density. You can, apart from the kernel density, you can also generate a cumulative density plot. We'll look at that very soon, which tells you the cumulative probability of a particular variable. And using that, you can understand the percentage of the data point below a particular value. So if you say, I want to know the percentage of the quantity demanded of gin bitters below 150 bottles, you'll be able to use a cumulative density plot for it. It's very useful for comparing distributions, and it is always increasing. It will never fall, and because it's cumulative, okay? And using that, you can see if one group tends to have a higher or lower values than another group. For example, let's say you want to compare the quantity demanded across occupation. You can use that to determine whether a particular occupation, say teaching, has got a higher quantity demanded than another group, say fishers. You can use that. And it can help you to determine the spread or the skewness of the data. For example, you can ask what percentage of the shops have got a quantity below 180. You can use the cumulative density probability plot to be able to answer that question. Okay, now I'm about to show you something related to the density because it's very important to me. The density plot and the cumulative density plot. But the facts are the following. Higher values, when you have the density plot, and it has peaks. Remember, the peaks are the higher portions of the band. If you have a higher peak depicting higher mode, okay, that's what it means. So let's say that I've drawn 3 of them. One of them has got a high peak, and you're going to see an example. It tells you that majority of the data is highly concentrated there. So there's a high concentration of data. A single peak tells you that we are dealing with a unimodal distribution. A double peak, okay, a double mode or a double peak, where you have the mountain top, to be 2 different mountain tops. That is bimodality exhibited. When you have more than 2, you have multimodality being exhibited. Okay. Now, if the curves are wider, it means that more data variability is existing. If they are narrower, if the peaks are narrower, it tells you that there is tighter clustering around the values within the data. Okay. If the curve is no longer on the right, the data is right skewed or positive skewed. And if it's longer, on the left, so very longer on the left, then it tells you that it is left or negatively skewed. Let's take a typical example of this. So this example, 1 observation, just 1 numeric variable, quantity demanded. Okay. Now, this is a general way to determine the normality of a data point. That's a general way that you want to determine whether a particular data point is normal or is not normal. Now, let me tell you something. I changed this. If you say that the bandwidth method should be 1, okay? If the bandwidth method is 1, then you are forcing everything to be normally distributed. So if you check your command that I gave you, if you do the KD plot, the kernel density plot for quantity, and you say the bandwidth method is 1, so you've already forced the bandwidth to be 1, then it means that you are forcing this thing to be normally distributed, which is what you see here. But the question is that you cannot force this thing to be 1 unless you use a certain approach. But then this bandwidth method assumes that you use a certain approach, so the bandwidth becomes 1. And the bandwidth method, if it is 1, normally distributed, and you run it, you get normally. But when I remove the bandwidth method here, okay, when you remove the bandwidth method and run it, you are going to get the actual original distribution of the quantity demanded, which we already know that it is multimodal. There are 2 peaks, so it's exhibiting multimodality. So quantity demanded is actually not normally distributed. That's what it means. But how do you tell? There's a test. Put it in your pocket. There's a test called Shapiro-Wilk test. The Shapiro test can be used to determine normality. So the Shapiro test can confirm. I've done it already. The Shapiro test, but we'll not come to that section. It will confirm and tell you that truly quantity demanded is not normally distributed. Okay, let's go. So that's for a single variable. Okay, and you can see, in fact, let me just introduce the bandwidth so that it doesn't conflict with this. This is second one, is the one I just did here. All right, now, if you check carefully, we are going to look at quantity demanded across 2 different numeric variables. So the numeric variables here are price and that of income. So if you look at price and income, we can check carefully which one is more likely to be normally distributed, which one is less likely to be normally distributed. Who can tell me? Price and income. By the way, the red one. Oh, by the way, you see the way I've written the color red. If you add the full name of red, I just use the letter R. That reduces the transparency. So if I type the full name of red, watch it, and I run it, it increases the transparency of the red. but reduces the what do you call it? It increases the opacity of the red, and then still increases the transparency of the blue. But let me switch it. You look at the color of the blue. Let me make it full blue by typing BLUE. The blue will no longer be as transparent as it is now. Let's run it. Okay. So the blue now becomes very, very, concentrated. So that's one way you can reduce the concentration or increase it, depending on what you are looking for. Just so you know. So now let's make it transparent. Okay. There you go. Both of them are now transparent. So the red is for income, and then the price is for the blue is for the price. So who can tell me which one is more normally distributed? And what about the other one? What can you say about the other one? Anyway, which one is more normally distributed? And what can you also say about the other one? The other one that you think is not normally distributed. You notice clearly that the income, you notice that the income is not as normally distributed as the price. The price is more normally distributed than the income. The income is exhibiting multimodality of the data set. And that is one thing that you can do. Remember that the y-axis here is showing the density, not the count. It's not the number of observations. It is actually showing density there. Okay. It is the estimated probability of the values happening in different ranges. That's what this one is showing. And in case you probably don't know by now, the area under the normal curve is always 100%. So you can always use this to compare the shapes, different distributions across occupations, across religion, across location. You can do that. Let's take one of them. So this is across location. So you use this one, watch it carefully. I use a data set. I'm still using the quantity demanded, which is a numeric variable. Okay. I am classifying them according to location. Okay. I want a fill. So the fill is what? In fact, you can remove the fill and make it false, so that when the fill is false, there's no fill. Okay. When I run this, okay, see right now there's no fill. The thing is there, but there's no real fill. Okay. So if you don't take care, you will not really see the, what do you call it? I have the ragbed also here showing. If you want a particular alpha, let me just change the alpha a little bit. See, the alpha here, I changed it to, it brings about the color. Let me just make it 2. Let's see. Oh, I didn't do that. It didn't work. I'll try it again. Okay, so it's exceeding. Okay. So you can see, so you can show the graphs like this if you want, but if not, no problem. But that is just to show you the different ways of it. And then of course you can still go back and then fill. Okay, so let's fill, and then everything comes back to what it was. Once again, you can edit it. But my interest is this. So suppose you have this. You can see that urban is showing things on the right. Urban is more to the right, oh, don't forget. Rural is more to the left. Okay. So in this case, the two locations are overlapping. I don't know whether you can see it. But the here is that the key point is that the curve that is further to the right will show higher values. So you can see that there are more shops that are selling higher quantity demanded of gym bitters in the urban centers than in the rural centers. Because the urban centers is to the right of the rural centers. And the higher right you go, the bigger the quantity demanded. So that's the first observation. that the urban centers are selling a higher number of quantity demand bottles of quantity demanded of Genvitex than those in the rural areas. The urban centers are winning in that particular regard. Now, when you look at the peak, what can you say? Because if one particular peak is higher than another peak, then it tells you that there is a lot of greater density of the quantity demanded for the higher one. But when you look at the two that we have here, what do you see? When you look at the two, you notice clearly that there is not much. Okay? The two locations overlap, indicating that quantity demanded of rural and urban areas have similar distribution. Since the curve is not distinct between the two, it tells you that there's a lot, there are not meaningful differences between the two groups in this case. And that is the comment that I need. And those are some of the comments you'll be writing to indicate the data that you have. Okay, so that's for location. So you can look at a particular numeric variable across several groups. This time I decided to do the same thing, but rather across, see this one, rather I want to do, let me run this again. Across religion. So you can see I've done one across religion here. So for religion, you see that the one that has got more to the right are Christians. Christians are consuming, I mean, you will notice these things throughout the other graphs we have shown. Okay? Because other graphs have already shown this that we are talking about. Just that I'm using different graphs to show the same thing. So in an exam situation, I'm not going to give you all the graphs. I'm going to give you some selected graphs that say the same different things. So if you look at this, the green one is representing Christians. It is more to the right, which means Christians are consuming a lot of augmentation. Okay? Because the peak of that is around, it's even about 200, of the quantity demanded. So there's a lot of, consumption that is being made by the Christians. But all of them are showing multimodality. All the density plots are showing multimodality. They have two modes, which means that a concentration is not in one particular number. Majority of the data points are concentrated in two different numerical areas between the two. And that's what you can see here. All of them have got that sort of multimodality. All right. How about occupation? So look at occupation here. I had to do the same thing for occupation. Now, if you look at occupation, it's very beautiful and it's very, very interesting. Okay? Because if you look at occupation, check the graph, you will see that fishes are on the far right. That's what it means. Okay? So we already know that the area under the curve is 100%. So that should tell you that majority of the fishes are consuming quantity demanded, because this variable is quantity demanded. If it was price or income, it would be different. Also, when you look at trading, okay, trading has got a very narrow curve, unlike the rest that have got a wider curve. Okay, it has got a narrow curve here, and it also has a tail, narrow peak. If you look at the peak, it's very narrow. The peak is narrow at 140 quantities demanded of bottle. It's not wider, okay? Which tells you that it has low variability. That is what it means there. There's a low variability, okay? In other words, majority of the quantity demanded are around 140. And for fishing, majority of the numbers are around over 200. Let's say 210. So that is one observation you can make there. Most of the quantity demanded in teachers, if you check carefully, most of the quantity demanded among teachers are around 160 and also around 190. So it's got two peaks there, and it's got some around 160. There's some around 190. That's another observation you could make there. You'll finally notice that fishes, they have got a wider curve. In other words, the curve is much wider, you know, which means there is more diversity in the values. We already know that majority of them are concentrated around 210 thereabout, but there's still more diversity in the quantity demanded, okay, which also has highest quantity demanded of gene bitters. So when you look at occupation curve for this last fishes, okay, it is shifted to the right. If you check this very one, for the teachers, it's shifted more to the fishes. Okay, it's shifted more to the right here than if you check the other ones. So those are some things that you could say. You should be able to identify. Always talk about the following. I've said it. Talk about the density. Talk about the peaks, which is the modality. Okay, and talk about whether it is on the higher level or on the lower level of the graph. You discuss that. Now let's go to the cumulative density. This is a cumulative density for quantity. There's a lot of things you can also see here. And you can also say a lot of things here for the cumulative density. For example, the first thing you will notice is that this horizontal line, okay, that is where majority of the stretch happens. So remember, cumulative density is showing as it tops up. So first thing you will notice is that 80% of the observation have quantity demanded less than 200. How do we know that? Well, check the 200 level. You see this section here? A lot of people don't know how to read this. This is 80% of the observation. This is 100% of the observation. And if you look at it, 80% of the observation is here. This point here is 200, as you can see, for the quantity demanded. So that means that 80% of the observations have got values 200 or less. Okay, they've got values 200 or less. That's a very, very good. And then the rest of the 20%, only 20% have got values above 200. And remember, the maximum value is 220 anyway. So majority of them is very, very useful to use the cumulative density function because it's able to tell you some interesting things. That is not the only thing. If you check the slope, is it very steep or very flat? Okay, some of them are very flat. For example, cumulative density, if it is steep, it will go like this. Okay, very steep. Okay, it's like when you climb it, you fall down. Or if it is very flat, it will go like this. So clearly, let me put it this way, like this. So when you have something like that, what does that mean? Well, in our case, the slope here is not steep. If you check it carefully, it's like almost within 45 degrees, so it's not steep. So any data points are not close to each other. That's what it means. So there is no dense region. You don't have a very densely populated region. Okay, because when they are close to each other, then we can say that there is a dense region. There is rather a very flat, relatively flat slope, which tells you that the values are more spread out. In other words, the values are less frequent than you can see. Remember that the median is here. Remember 50% is the median. So if you look at this, if this whole thing is 100%, 50% is here. And that means that 50% will match at this point. So it means that the value here, which is 160, is the median. And that is why y is equal to 50%, or where the proportion here, that's a y, is equal to 50%. Now the minimum value is known here. This is a minimum value. So the minimum value here, which is in this case 0% level, that is 130. So using this graph alone, you can tell which value is a minimum value. You can guess that, oh, the minimum value appears to be 130 here. And the maximum value appears to be 220 there. You can tell. Okay. In this case, this curve, particular curve here, it flattens. It flattens at the median. You can see it here. So at the median, it flattens. And then it rises again, you know, at 190, and then keeps going. But other than that, it was the same until it got to the median position and then flattened and then rose up. What's the point? The point is that you can use the cumulative density function to be able to tell you a lot about a particular data point. All right. Now, Varlin, very, very useful graph. Okay, Varlin. Here is a Varlin plot. This is a typical example of Varlin. What I want you to notice is that the Varlin combines the kernel density plot and the box plot. The box plot is the one in the middle there. This one, that's a box plot. It's inside. It's inside the Varlin plot. This is for just quantity demanded. The Varlin, when you look at the way it looks a lot, and you remember the violin, you know, an orchestra, you have those who are playing the violin, those playing the trombone, those playing the saxophone, those playing the, you know, all the other things, trumpets and everything. The violin, that's how this thing looks like. So what is on the left here and the right here are the kernel density plot. And what is inside here? So it is not, look at it, look at the point I've set here. It visualizes the distribution of a numeric variable for one or more groups. It plots, the plot gives you more detail than the box plot, okay? Because the box plot can hide certain features of the data. The Varlin will not do that. It can reveal the shape, that is a probability density, the spread, okay? That is a variability. And then the central tendency, that is a center. It can give you all of this better than the box plot alone will give you. Okay, so that's really cool. And then if you look at the weight, okay, the weight of the Varlin, the weight will give you the density estimate, how likely values are at different points. We've already seen this above. Okay, so if you have wider sections, it tells you that there is high probability density. That's more data point. So if it is wider. Okay. For example, you're going to see that some are wider, some are not wider. For example, this one here, Christians here is wider than this. So the point we are saying is that if you have that wider section, there's more probability density, more data points there. The wider section. The narrower section tells you that there's lower probability density. So few data points are there. So when you look at this very example here, there's wider section here and there, okay? But then in here and here, there's not wider thing. So there's more probability density. There's more data point at the 200 section, okay? And there's more data point at the 150 sections. But then there's lower probability mass, low data point around around 170 thereabout. So that is the point being discussed there. Okay, another point is that a white dot or a thick line inside the Varlin will tell you the median. And you can see this here. So that center here is the median. So you are already able to know whatever box plot will give you. Guys, use Varlin when you're doing your research. Use Varlin plot when you're doing your research, okay? Especially when you have groupings. Let's say you're comparing banks and then you're looking at groups, foreign banks against domestic banks. Varlin will do the trick for you. All right. Then, if you have a thick black bar inside the Varlin, it tells you the interquartile range. So you see that this whole thing, that point at the edge here and that point at the edge here, okay, it tells you the interquartile range. That is the upper quartile and the lower quartile, the 25th percentile and the 75th percentile. So up here is a 75th percentile. Down here is a 25th percentile. It tells you as well. So here you can know the values that are corresponding to that around 200. And here too, you can know the values around 150. But there's more. You can see that some Varlin plots will give you very thin lines. Okay. Like at the edge, you see some thin line. This one didn't give. Okay. But at the very edge, you see that you go teeny, very thin line. Okay. Now, those thin lines, okay, are the whiskers. And they extend to the minimum and to the maximum values within the 1.5 percentile interquartile range. So it tells you, in other words, you can use it to do most of the things box plot is doing for you. And use that. And now, of course, if they are outliers, they will also be pinpointed. So what is an advantage of the Varlin? I made a typo here. Okay. So here I meant to say Varlin plot. So between the Varlin plot and then the box plot, what is it? Varlin will give you the density. Yes, box plot will not. Varlin is unable to show outliers except when you force it. Okay. And if you believe that they are outliers, you can use another one to rather detect outliers. But apart from that, the others will be good. Box plot will tell you outliers easily. Varlin will show you the median and the interquartile range. Box plot will do the same thing. Okay. Varlin is good when you are dealing with large data sets, okay, but not exactly for small data set. Well, I can tell you that for me, both of them are good regarding that point. All right. So you can use the Varlin and compare this. We've said this many times. So you can see that just using the Varlin, it tells you that there's much concentration. So you're not only talking about the median and saying that Christians get more quantity demanded than Buddhists. Buddhists get more quantity demanded than Muslims. No. Apart from that, yeah, of course, that's good. Apart from that, you will notice also the majority of the information among the Buddhists is towards the upper part of the box plot within the Varlin than all the other two. And you will also note that there's a wider distribution of data points around 200 for the Christians, than for the rest. So there's a lot of distribution of the data points around 200 for the Christians and around 160 for the Muslims. So you can tell a lot of things in there. There are other ways of showcasing the Varlin. These are different Varlin plots. The same Varlin plots across religion. Okay. Look at that. So here, it gives you more. It comes with the lines, actually. Look at the beauty. You see the beauty? It tells you, it's not only showing you the mean, I've also superimposed the Streck plot or the Swan plot in there. Okay, and it tells you more concentration of the stretch. For example, when you look at the Muslims, okay, around the wider distribution of 160, the Streck plot is showing more concentration. That concentration, that's what you see in the red dot. You see, that red dot is telling you that there is more concentration of the data around 160. That is why there are so many red dots around 160. And I don't know wonder the Varlin there is stretching wider. And then when you look at here, for the Buddhist, it is stretching wider between 200 and 190. Okay, no wonder the red dots between 200 and 190 are the same. They are the same, okay, for the Buddhist. They are the same there, and therefore the Varlin is stretching. The Varlin is wider at that section than any other section in the world. Okay. So there's probability, mass concentration of probability, okay, in there. And then the same thing when you go to the Christians also, it tells you where there is that concentration in there. So that's another way of showing that. You can check it. And then when you want the graph to look very, very obvious, okay, like this last one here. In fact, you see that when you want the graph to look very, very obvious, you had to reduce the size because the size was too big. So this is occupation. And occupation, if you check it carefully, there are so many things you can say also about occupation. So today I've spoken a lot about religion. You should learn several other things. The key point is understanding the way the thing looks. It's giving the same thing, but I decided to use a different violin look. Now, the reason why this thing is looking thick is because the line weight, I increase it to 5. If I change the line weight to 1, okay, everything is smooth like this. Okay. Other than that, if I take it to 6, it becomes thicker, as you can see right here. So there are several ways you can examine those factors. And then finally, there's another look of the violin, okay, where you make it very plain, still for the occupation. I've added the swan plot or the B swan plot in there. If you add the swan plot, for example, look at this last one. I can show a B swan plot of these occupation and all of that. So this time I'm just showing the B swan plot. It tells you the concentration according to this particular one. It tells you all of the concentrations there. So just familiarize, but more importantly, understand the meanings of these graphs. Understand the meanings. Understand the meanings that when I tell you, I give you a scenario and I tell you that I can put 4 different graphs there and I tell you, give me 3 unique comments about these graphs. Compare these graphs based on what you see. You should be able to tell me something. Now, the last one for today is correlation. Correlation. As you know, correlation is just showing the relationship between 2 factors. What is the correlation between quantity demanded and price? Is it positive or negative? Quantity demanded and price.
Negative.
What is the correlation between? Okay, good. What is the correlation between consumption and income? Consumption is positive. So here, remember in our data set, we have quantity demanded, we have price. So I decided to just plot price and income. Okay, that's what you see here. The red means that I want the color to be red. The edge color means that I want the edge to be, dark red. I can change it and make it dark. Okay. Or make it black. Let me just. So you can see that the edge of it, I've just decided to make it black. I can change this one and make this price and make this quantity. So that we just check the quantity demanded between P and M. You can see that it's clearly showing negative relationship. Q is on the y-axis, P is on this one. I can rotate them, turn them. I bring the Q rather here. I bring the P. I bring the P rather here so that P is on the y-axis. So you can see that there's a positive correlation between the two. Very beautiful. It's a quick way. Oh, Excel can also do this, so there's not a problem. You can also institute the graph, the regression graph. You can superimpose the regression graph on this. What I'm trying to say is that, guys, when you have your data set, there are a lot of visualizations you need to do. And I'm just showing you some of these visualizations. By the way, the fact that it's sloping from left to right means that there's a negative correlation there. If it was sloping from right to left, let me see whether I can get you one. Let's look at complement price and price. Okay. I've not done that, but let's see. Oh, it's still showing a negative relationship. Let's look at income and price. I'm sure that is even showing. Yeah, income and price is not too obvious. By the way, remember that you can't show a correlation between a dummy variable and a numeric variable. Okay, that's why I'm not looking at those ones. But then I'm sure you get a point. Okay. When the graph is going from left to right upward, then it is showing a positive relationship. But if it is left to right downward, that is a negative relationship. So correlation, it's a scatter plot. It's a typical example of factors that show correlation. Scatter plot is very, very useful for numeric variables. Take note, 2 numeric variables. And you can change, this is a pure scatter plot. You can use several other things. If you want to change the way they look, you can always use several other. I made this thing bigger, but you can reduce the size, okay, where it becomes smaller. Okay. I made the round bigger by changing this S to 200. I can make the S to be 300 so that the things will become big, big, big. Next one. You can also do a correlation. This is beautiful. You can do a correlation across groups on one particular variable. So let's say that the variable is quantity demanded. So I want to look at the relationship between quantity demanded and price. Okay, let me just say quantity demanded and price. But I want to look at it across religion. So the hue is religion, the style is religion. And then I just show it. So look at the graph. Quantity demanded at price is still negative, as you can see here. It's still negative. But what is great is that I'm able to detect the Muslims. So you can say that, yes, generally they are all negative, but look at the Muslims. This is what helps you in classification, by the way. The Muslims is showing a bit of still negative within the Muslim. These are that of the Buddhist. Okay? That is also seemingly showing a bit of what? Negativity. And then look at that of the Christians. It doesn't look too clear about what is happening. It's like for them, they will still continue the acquisition. So, but the point of the exercise here is that you can look at how the correlation is different, how different the correlations are across groups, And the scatter plot will show you different groups and how the correlations are shown. In fact, you can even bring the regression line. So let me just go and do quantity demanded and price, and this time with a regression line. Okay. So remember, I'm using LM plot to indicate the regression line, but also across groups. Okay, across group. Now look at it. You remember we said that they were all showing negative relationship, and you can see that they are all showing negative relationship for each group. For each group, you're able to sense the correlation within each group. Sometimes you don't want to put all of them together because of group heterogeneity. So you might want to put them separately. And that is an example of what I just did. You can also do a scatter plot together with connected lines. So this is an example of it. Okay. Now, a connected scatter plot sometimes is called a line plot with markers. It's very, very similar to the scatter plot, but you have added lines that connect the data points in the order they appear. Okay. It's very, very useful to visualize the temporal or sequential relationship between two variables. Let's look at an example. So you can look at these groups and you can check how are they connected. Okay. Now the one I have done, let me just do quantity demanded and price again. So this is that of the quantity demanded and price, but across occupation. And you can see how they are connected. It shows you the connection. Some of them are separated with each other, but also shows you the connection. Of course, if they were time varying, you can include the time dimensions as well. The connected scatter plot is very good, especially when you have time. So you can observe several charts. One particular chart you can look at is two density graphs. Very useful. They are called contour lines. Contour lines. Let me show you one of them as far as our religion is concerned. So we can do contour lines between, let me do for price and quantity demanded. In other words, what you are doing, see, try and learn about contour lines. Okay? See, it is still showing the negative relationship between price and quantity demanded, but it tells you also the concentration. Okay? There's some concentration here, and then there's some bit of concentration there. But when you look at the way the contour looks like carefully, okay, it tells you something. Each contour encloses, okay, it encloses the area of equal density, like you might see in a topographic map. And you can see that clearly that there's some areas here that are more plain, okay? So if the lines are closer, like what you see here, if the lines are very, very close, it means that there is a steeper density change. More data is packed here in this particular region. More data is packed here in this particular region. That's what this one is showing. You can use it to detect clusters. So clustering tend to use it. You can use it to detect relationship. You can even use it to tell whether quantity demanded increases when there is an increase in price or when there's an increase in anything. It can also bring about outliers, because outliers will be those lines that will be stretching the lines. In our case, we don't have outliers, so there's no problem. And you can also use it to compare the distributions across particular groups. So contours are good. These are contours showing these two. And this one is the same thing, but let me just change it to price now. I've just decided to create a C map. And you can always add a C map because it's the same thing. Let me just run it first for you to see. You see the way it is? The concentration is still showing here like it was before. The same thing here. There's concentration on this top left here. Concentration on this bottom down here. Okay. And you can change the reds. You can change the reds to blues. You can just say blues. Okay. And then you can have the concentration in different blues. Let me try another one. Okay. We're using different. If you want it in greens, you can have it in greens. I just want you to know. So all of these things, you can just familiarize yourself with them, and then you will know how it just tells you the concentration, but it's not only telling you the negativity and the correlation. No, negativity and positivity. It's also telling you the concentration. That's it, the concentration. It's beautiful. It's beautiful. And then you also have bar plots. Bar plots, again, I did for urban and rural. It will show you how they look like. You can even put the numbers on it. Bar plots is a simple thing that majority of plots tend to look at any point in time. So that's it, ladies and gentlemen. That brings us to the end of the entire caboodle. Now, if there is anything you don't understand, please, this is the moment. Okay? This is the moment you can just ask me, and I can address it beautifully. Any question at all? Beautiful, beautiful.